Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Bono Discovery Center. Today we're going to be looking again at differential calculus. We continue with differential calculus. The subtopic that we're doing today is the equations of tangents, and we're going to draw some cubic graph, the cubic function. So we're only going to do the equations of the tangent. But the lesson that we're doing today is a continuation of the lesson that we have done previously. The objective of today's lesson, that is, after today, you must be able to do the following. Otherwise, you must be able to determine the equations of the tangents to the graphs of functions. You need to be able to sketch the graphs of the cubic polynomial functions using the differentiation. Remember, we're going to use differentiation that we have done previously to determine the coordinates of the stationary points. So stationary points is nothing else but your turning points of the graph. We're going to determine which one will be the maximum, which one will be the minimum. Lastly, you need to be able to determine the x-intercept of the graph using the vector theorem and other techniques that we have done previously also. So we're going to look at it now. The first thing that we're going to be doing there, it will be the equations of the tangent at a given point. But first of all, let us explain this. If I'm given a function, remember the f is the name of the function. Okay, so the minus 2x squared, it is that function that is given there. So we need to calculate. Remember when we're doing the polynomials, we did this. So we said, if I want to substitute, if I want to get f of 1, what does f of 1 mean? It means that I need to substitute the value of x by 1. Substitute x by 1, what answer will I get? So if I take f of 1, I need to take the equation that has been given, substitute the value of x by 1, and that will be equals to 2 into 1 squared. So that answer there, and we'll see a lot of mistakes to the learners when they're using a calculator. They put minus 2 because they know that minus 2 times 1 will be a minus 2, and then they square the minus 2. No, you don't do that. So first we're going to square 1. Remember, with exponents before we multiply. So we're going to square 1. We say 1 squared is 1. 1 times negative 2 will be negative 2. Or put it as it is in the calculator. The answer that we're going to get there is minus 2. But what does this mean? What does f of 1 mean? It means that the value of x is 1. What will be the output? So the output, remember, is a dependent value. So the minus 1 is an independent value. So what does this mean? It means that these are the coordinates of that point. So in other words, if x is 1, the y value will be negative 2. That is what it means. So in other words, it's a point on the graph. So if I have to draw this graph, I realize that if the value of x is 1, the value of y will be negative 2. So that is what it means. So to find the value of y when x is equals to 1. So if I'm given the function, the value of x is 1, then I just substitute it there and to get the value of y. Now f prime 1 there, see that sign there, f prime 1, what does that mean? So what does this mean? It means now, remember we have done rules of differentiation. You have derived. So it means that I first need to derive, and after deriving, you check the answers that I was going to get there. So first of all, I'm going to say f prime x is equals to. In other words, now I'm deriving that one. So remember, when we derive, what do? We take the 2, we multiply it with a coefficient there. So if I multiply the 2 by the coefficient, I'm going to get negative 4x. Then I need to subtract 1 here. So if I subtract 1 there, I'm going to get a 1 here. So now I need f prime of 1. Then I can then substitute. So if I substitute the value of x by 1, I'll get 4 times 1. Remember, it's to the power of 1. My answer there is going to be negative 4. Now, what does this mean? It means that, remember when we derive, what are we getting? We're getting gradient. So in other words, it means that f of 1 here, f prime 1 here, means we are now getting the gradient. So that is the gradient. Gradient where? At a point. Which point am I talking about? At the value of x is equals to 1. So the gradient of the line at x equals to 1 will be a negative gradient. In this case, it will be negative 4. Just a quick scenario of what I'm talking about using the graphs. If I draw a graph, if I draw the graph of that, it will be a graph which is facing downward. Right? The a value is negative, so the graph is facing downward. So now, if I talk of 1, so 1 will be somewhere there. Alright? This is the point at x is equals to 1. If we have a 1 here. So if I want to draw the gradient at that particular point, my gradient will be in this direction. So that is the gradient of that line. So that the equation of the line will pass that at that particular point of 1. So if it passes there, you can see that the gradient of that line is negative. So that's why we got a negative here. Okay, so for us to get the 4, we'll show it in the next slide. So how do we then go to negative 4 and how do we then get the equation of that line? So we will be doing the equation of that tangent. But for now, I'm just wanted to show you that the gradient of that line is negative. So at x equals to 1, the gradient there will be a negative. If I wanted the gradient at x equals to negative 1, so if it's negative 1, my gradient there will be a positive gradient. Okay, so we are doing the gradient at a point. So we want that equation of a tangent at a given point in this case. So for this one, we now know that if I talk about the derivative, I'm talking gradient. So if I derive, I get a gradient. Okay, right. Now let's go to example number the next activity there. In the next activity, you are given g of x is equals to half x squared. So that is the function that has been given, is a g function. The first question here says determine g at -2. What does this mean? It means that we're looking for the y value when x is equals to -2. So in other words, we're looking for a point. So now, g of 2, must I derive? No, because I'm just looking at for the corresponding value of the coordinates that I'm having here. So I'm having x is equals to -2. So I'll go here and say for x to be -2 means that wherever I see x, I'm substituting it by -2, but that is squared. So I'm now going to get half into -2 squared, it's 4. So I'll get a 4. And then from there, half of 4 is 2. So what does this mean? It means that I've got a point here, -2 and 2. So my point here is -2 and 2. My x value is -2, it's this one here. My y value is the one that I've got here, which is going to be 2. So I've got the x value and the y value. So my coordinate there is given there as -2 and 2. But this is not what was asked. We are only requested to find the value of g of -2, and that answer was 2. Okay. Right. B says now determine the gradient. So that word gradient of the tangent of g at x equals to -2. So how do I then determine the gradient at that point? So The first step that we've done is to get the g of -2, which gives us a point. The next one then is say find the gradient of that point. How do I get the gradient? Remember I said gradient is nothing else but we need to get the derivative of that. So that is why I've done that activity number 1. So now we are having g at x is equals to half x squared. So now I need the gradient. So to get the gradient, we need to differentiate. So I'm going to differentiate. The first thing that we need to do is to differentiate. So I differentiate. So half x squared differentiated will give us, remember the 2 must multiply with a half. So if I multiply the 2 by the half, I'm going to get 1. So I subtract an x, a 1 there, so I'm going to get the x. So g prime x will be equals to derivative of g of x will be equals to x. Now this is where I now get the gradient at a point. So gradient at a point means I must substitute the value of x by -2, which means my gradient will be nothing else but it will be -2. So I have a gradient, I have a point. The next question, obviously, it will be determine the equation of the tangent, or determine the equation. Okay, right. In this case, it was equation of the gradient of the tangent. Now we need the equation of the tangent. So remember, for us to get the equation of the tangent, what do we need? We need a point and a gradient. We need a point and a gradient to determine the equation of the line. So for us to determine the equation of the line, we need the gradient. So our gradient is -2. The point that we got there, remember the point that we got was -2 and 2. So if I've got a gradient and a point, it's much easier for me to get the gradient, the equation of the tangent. The equation of the tangent, remember, how do we get the gradient? How do we get the gradient? We differentiate it. For us to get the equation of the tangent, what do we need? We need the equation of a straight line. What is a tangent? It's a straight line. So in other words, at a point, remember it is at a point. So x minus. Remember, if I can just quickly draw that sketch will be facing upwards. So it's facing upwards. My gradient at a point will be at -2. So the point that we're talking about is this one. The tangent, remember a tangent is that line that touches that graph at only one point. So that will be the tangent of that graph. So if I need to find the tangent at that particular point, what will be the tangent? What will be the equation of that line? That's the picture. So now I need to substitute. Obviously, if I look at my graph here, is decreasing. So if the graph is decreasing, what will be the gradient? Gradient will be negative. So for the decreasing function, the gradient is negative. So let's see, are we having a negative gradient? Yes. Now we need to find out where this graph will pass on the x, or will cut the y-axis. So y minus y1 is going to be our 2. The gradient is -2. x1 is -2. So now I'm going to get -2x. Negative times negative is positive. Positive times this negative, there will be a positive. Sorry, it will be a -4. Then we've got y minus 2 on this side. So I can just transpose y equals to -2x -4 plus 2. So my y will be equals to -2x -2. So this is the equation of the tangent. So if I want to check if this is correct, in this case, I can check there. This graph there is a 2. So if I get the value of x will be -1. If I solve the value of x here, The y-intercept of the graph will be at -2, so I might be right, although this is not up to scale, but I might be right in terms of my positions of those points here. Okay, so at a point, touches at one point, then it touches at that point, which is at x equals to -2, and we draw that graph and then we can get it. Okay, I don't think this is very challenging. It's one question. I've just taken this question and scaffolded it in other ways. I've tried to do it step by step. The first part was to get a point, the value of y given x is -2. The second one, there we needed to get the gradient of the tangent. The third one is getting the equation. But in the next question, you realize that that question, the question was just determine the equation of the tangent given the graph at x is equals to 1. So you realize that if they give it like that, it means that all these three steps that we have done in the first one must be there. So you'll check, let's check that next one. You see the next one there, it's 5 marks, it's gonna be 5 marks, plus minus 5 marks. The question is just one question, it's not broken down into steps. In the first one, it's broken down into steps to say, get this, get that, and then ultimately get the equation of the tangent. With this one, the question is straightforward, just get the equation of the tangent, and they just give it 5 marks. So can we go back and remind ourselves about the steps that we need to take to get the equation of the tangent? The first step that we need to look at, remember, the first step that we're going to be looking at is to substitute the value of x there by -1. What are we looking for when it's substituted by -1? We are looking for the y value, the corresponding y value of that point. So if I come here and say f at -1 will be equals to -1 cubed minus 2 into -1 squared plus into -1 then plus 1. So if I take out my calculator, but this is easy to do. If I take out my calculator anyway, the answer there should be -3. Right, so f at -1 is -3. So we translate to this, that I have a point -1 and -3. So my y value is -3. My x value is given is -1. So my point. So what do I need next? So I'm done with the point. What do I need next? The next thing that I need is the gradient. So remember, if I've got a point, I need a gradient. If I've got a gradient and a point, I can do the equation of the line. So those are the main 3 steps that you need to understand for you to get the equation of the graph. So it means that now I need to get the derivative. For me to get the gradient, I need to get the derivative. The derivative of this one will be 3x squared minus 2, minus 4 x plus 1. So if I derive this 3 times that, it's 3 minus 1. 2 times this is 4. 1 times this is 1. Then we're going to get that derivative. After getting this derivative, which point must I substitute with? -1. So in other words, I'm substituting the value of x by -1. What am I getting now? I'm getting the gradient at -1. So I'm getting the gradient at a particular point. Remember, in grade 11, when we did the gradient in grade 10, we used y2 minus y1 over x2 minus x1. But in this case, we don't have 2 points. We need gradient at a particular point. That's why we use the derivative. So now we can then get our answer there. If we work this one out, I think we're going to get a 3 there. You are going to get a plus 4 there. And then we are going to get a plus 1 here. So the answer there will be 8. So which means that the gradient is going to be 8. I have a gradient, I have a point, I can now get the equation of the tangent. You see you have quite a number of steps that you need to work with there. So I need to find the equation of the gradient. So I'll have y minus, remember I'm using this point. So it's y minus into minus 3. My gradient is 8. I have x minus into minus 1. And then I'll have y plus 3 equals to 8x. Remember, this is a plus. So we multiply by 8, we're going to get plus 8. Then the y will be equals to 8x. If I take over the 3, I'll get 8 minus 3, which is going to be plus 5. Then this is now the equation of the tangent. So you can see the 3 steps that I've done there. I've just indicated that. To say the first thing is to get the point by substituting directly into the equation. Secondly, you need to derive and substitute. Once you derive and substitute, what are you getting? Gradient. So we've got a gradient and a point. Then we use the formula for the straight line. Remember, you can still use the formula y equals to mx plus c, where you're going to first get the c. After getting c, then you substitute it back. But this formula here goes directly to the equation. So with the other one, you still need to substitute the value of c into the final equation. Okay, now we are going to take a short break, 2 minutes, then we'll be back. Okay, welcome back. Let's just recap on that question. Activity 2, equation of the tangent. We said first step, point. Second step, gradient. Third step, equation of the tangent. Now, look at this activity 3. Now, remember, these questions are not going to come in the same way as finding the equation. Examiners will trick you in this one, in some of the questions. Now, look at this. But now you just need to read the question and understand. The first thing there, determine the coordinates of the point. That should be coordinates of the point P. Coordinates of point P at which the gradient, you see in this case here, the gradient, it's -8. So what is given? You are given the gradient. So what is missing? It's a point. Okay, so we don't have this point here, it's not there. That's exactly what it means. Okay, you are given the equation of the curve x squared minus 2x minus 8, but you are told that the gradient at that particular point is negative 8. So we need to get the point. That's what is missing. So how do we then, where do we start now? Remember, how do we get the gradient? We differentiate. So which means, if I differentiate the f of x, so I'll take f at x and differentiate it. If I differentiate f of x, I get a gradient. And that gradient is negative 8. So whatever I'm going to get when I differentiate it, I equate it to negative 8. Okay, so I'm going to say I'm differentiating that, so it's going to be 2x minus 2. That will give me negative 8. So now it's quite easy. I need to get a value of x. And if I get a value of x, I can get a value of y. If I get a value of y, then I now have my point. So which means I'm going to say 2x is equals to negative 8 plus 2, which gives me negative 6 and 2x. So my x value will be negative 3. But remember, I need the coordinate of the point P. So coordinate must be written as x and y. But I only have an x. So which means for me to get the value of y, I need to substitute. I've got f at x is equals to x squared minus 2x minus 3. Now I already know my x value, so I can just say f at negative 3 is equals to, then I substitute. I'll have negative 3 squared minus 2 into negative 3, negative 3. So I'll have a 9 plus 6 minus 3. And the answer that I'm going to get there will be 12. What is that? 12 is my y value. It's f at minus 3. So which means that now my point P now will be negative 3 and 12. See, the reverse of that. In that other one, we said we're looking for the gradient, and we're looking for the point, and we're looking for the equation. In this case, the question there just stated that just calculate, just determine the coordinates of point P. So my coordinates will be negative 3 and 12. I think the next question was supposed to be determine the equation of the tangent. That was going to be easy for us. Why? Because we already have the gradient, we already have a point. We can then use that to get the equation of the tangent. Okay, so we can get the equation of the tangent. Okay, so but in this case it is not asked, so we can leave it at that. So you stop there because that question was not asked. Okay, the equation of the tangent was not asked, so we're going to stop there and say point. What they're looking for is the point. So we've got the point, and we stop there. So if you, I want you to take this one and you can practice it further and get the equation of the tangent on your own and see if you can be able to get the equation of the tangent. Okay, right. You're doing very well. Now let's look at activity 4. Now in this activity, you are asked to, you are given that the equation of the tangent is defined by the f of x equals to mx plus c. So the curve given as g of x is x squared plus 3x minus 2. Now they're bringing in something else. Can you see the different kind of questions that you can ask here? They're bringing something else. They're saying that tangent here that is given there is perpendicular to this line of px. So it means you need to understand the word perpendicular with respect to gradient. Because the first question says calculate the value of m. The value of m that they're talking about is that gradient. So if the gradient of this one here is 1 over 9, and this line is perpendicular to that tangent, what will be the gradient of that tangent? So which means, yes, the gradient, what do you know about the two gradients? So multiply the two gradients, I get -1. Reason being they are perpendicular. So if I've got this line perpendicular to that line, the gradient of line 1 and the gradient of line 2, when I multiply them, I must get -1. So already I've got the gradient of one line here, which is 1 over 9. So I'll have the gradient of the gradient of line 1 times the gradient of line 2 will must give us -1. That's when the lines are perpendicular. I've got one gradient here, which is 1 over 9. Multiply by this gradient that I don't know. I'm just going to call it a perpendicular. The tangent, the gradient of the tangent, they must give me -1. So I can just divide throughout by 1 over 9, or just multiply by 9 on both sides. So therefore, if I do that, then I'm going to get that one to be -9. So the gradient of the tangent, so my value of m here will be -9. So I know that if I've got perpendicular lines, line 1 times line 2, the gradient of line 1 times the gradient of line 2 will give me -1. Okay, so please know this. Very, very, very important. That is in terms of the gradient, the perpendicular line. So already I've got the gradient. Which gradient is that? This is the gradient of the tangent. This is the value of m in this case. So I have the gradient of the tangent. Let's then get to the next question, because this is A. So we're still working in the same question. Let's get to B now. Now B, it says hence. Remember already what do we have? The gradient of the tangent. So the gradient of the tangent is -9. It says hence determine the coordinates of the point of contact. You see, it's the same, more or less the same question as the one that we have done there, but now they've added something there, perpendicular. So if it was parallel, the gradients will be the same. In this case, it's perpendicular, the gradient will multiply to give you -1. So now we are given the curve of G. So what do we know about the gradient? If the gradient is given, how do we get the gradient? The gradient, we get it by deriving. So let's derive. So it means that if I derive G at x, I'm going to get the gradient. And already the gradient is given. Oh, I calculated it. Not given, sorry. So now we're going to say, if I derive this, so I'm going to get 2x plus 3. The gradient is -9. Okay. The gradient can never be -1 over 9. Reason being, the lines are perpendicular. So if the lines were parallel, then the gradients will be the same. So in this case, the gradient is -9. So what do you do? Solve for x. Then to get this one is -9 minus 3. We get 2x equals to -12. And the x is -6. But this is not the coordinate of the point. It's only one part, which is the x value. So now I need to get the y value. How do I get the y value? I then substitute the value of x by -6. So I'll come here and say -6. Remember, I substitute into the original. Okay, so I'm going to have plus 3 into -6 minus 2. So I think there will be 36 minus 18 minus 2. And if I do my math there, I think that will be 60 16. So my point coordinates of the points will be -6. Remember, I must write this coordinates. So those are my coordinates. So that's my final answer. So it's the same question as that one, the one that we have done in activity 3, but this one is different because the lines are perpendicular. With the other one, we just requested to find the point of contact at P. But with this one, the points are the gradients are different, so we need to make sure that we understand perpendicular lines, parallel lines done in grade 11. Okay, so those are the different type of questions that are done in equations of the tangent. And please just make sure that we understand how to get the equation of the tangent. Three steps. First, point must have a point. Second step, must get the gradient. Third step, find the equation of the tangent. So if the equation of the tangent has been sometimes you're given the equation of the tangent and you really need to go back to get the point of contact. You must also do it. So also you need to go back and you can get the equation of the point of contact, and the gradient. Okay. Now let's move. I think that question in the exam, this question in the exam, most of the time got 5 marks, plus minus 5 marks. So this is a question that everyone must get. Okay. Right. Let's look now at the sketching of a cubic function. I'm going to start by writing down the equation before I can do that question. So remember the equation of the cubic function is the graph y equals to ax cubed plus bx squared plus cx plus d. Okay, so that is the function. So the A tells us the shape of that graph. The D is the value, is the y-intercept of that graph. Remember, this graph will only have one and only one y-intercept. Okay, so we cannot have two y-intercepts on this graph. Okay, and the x-intercept, the maximum number of the x-intercept will be 3 because it's cubic. So the maximum number will be 3. Okay, right. So I'm going to start with the stationary point. But before also I start with the stationary point, I'm just going to share with you how we can then know which shape is which. So for instance, if my value of A on this graph is less than 0, so in other words, it's negative. The shape of the graph, you realize that our shape of the graph will start by decreasing and then increasing. So the graph is going to start by decreasing and then it increases and decreases. When we draw this sketch, you will see. Okay, depending on whether you have your x-intercept correctly or not. Okay, when the A is greater than 0, the sketch here is going to start by increasing, decreasing, and increasing. So in other words, the graph is going to start by increasing, and then it's got the stationary point, and then it decreases, and then from there it increases. Right. So that is the shape of that graph. But you realize that when you draw, you must first get all the points. So it's a 4-point plan on how to draw the sketch. First, get the y-intercept of the graph. Number 2, get the x-intercept of the graph. Number 3, get the stationary points of the graph. Number 4, we need to look at sketching the graph, how to sketch the graph. Okay. But here, first, I'm going to start with the stationary point. So with the stationary points, remember when you do the stationary point, I said we look at the A value in this case. This is a quadratic equation. It's not a cubic function. It's a quadratic equation. But I just want to show you how we can justify the stationary point. With the quadratic equation, it's much easier because I know if the A is negative, the graph is looking downward. Which means that this point that is there, stationary point, remember it's stationary point, that's where the gradient is 0. So we're saying at that stationary point, what type of a stationary point do we have? Do we have a maximum stationary point or a minimum stationary point? In this case, we're going to have a maximum stationary point. When you have a minimum stationary point, that's when we have something like this, which is the minimum, right? So let's check this one first. First, we need to determine the stationary point. How do I determine the stationary point? Remember, stationary point is when the gradient is 0. So in other words, how do I get the gradient? The gradient we differentiate. So I'm going to differentiate this one. We differentiate plus 6. And after we differentiate, we equate this to 0. Why do we equate it to 0? Because at the stationary point here, at the turning point, the gradient of that line is 0. It's not a gradient, it's a gradient at the stationary point is equals to 0. So that's why we equate it to 0, not to any other number. Then we have our x value is going to be, if we work out our x value, there is going to be 3. So in other words, at x equals to 3, then we need to find another point. How do I get the point? We substitute it into the original. So I'm going to say negative into 3 squared plus 6 into 3 minus 3. So if I do that, the answer there is going to be negative 9 plus 18 minus 3. If I'm not mistaken there. So the 6 there, so that's fine. So that's 6, we substitute there, that will be 3. So we substitute, so that will be 18 minus 9, which is 9, and then 9 minus 3, which is going to be 6. So the point that we're looking for now is 0.3 and 0.6. So in other words, the graph there will have its maximum at 3 and at 6. Okay. So which means, why am I saying the maximum? Because the graph is facing downward, and the graph is facing downwards, the maximum value will be there. Okay. In the next one is different. The next one we have a cubic. Yes, that's what we want. We have a cubic. So when we have a cubic, we have a different story now. Remember I said when the A value is positive, then our sketch will look like this. So our sketch will start by increasing, decrease, and increase. So in other words, the first one will be our maximum. The next one there will be our minimum. So the first turning point will be your maximum, the next one will be the minimum. When A is less than 0, the first point will be the minimum, the next point will be the maximum. But let's check on this one. How do I get a stationary point? I'm going to differentiate. So I'll get 3x squared minus 3. Then 3x squared minus 3 is our gradient, and our gradient must be equal to 0. So if I divide throughout by 3, I'll get x squared minus 1 equals to 0. So I'll have x minus 1, x plus 1. There's a difference of 2 squared. So I factorize it. So I'll get x equals to 1 or x equals to negative 1. So can you see now in this one, because it's cubic, now we've got 2 turning points. We've got 2 stationary points. So at x equals to 1 and x equals to negative 1. So we need the corresponding y values. So meaning that I substitute the value of x by 1 in the original. Remember, we substitute in the original. If I substitute x by 1, I'll get 1 minus 3, which will give me negative 2. Or if I substitute by negative 1, I'll get negative 1 plus 3, that will give me a 2. So my 2 points here, my 2 stationary points will be 1 and negative 2. The other one will be it will be negative 1 and 2. So if I can just quickly check which one will be the minimum, which one will be the maximum. If I draw my sketch here, so if I've got a negative 1 here, so here it will be 2. If I've got a 1 here, that will be negative 2. You see, so which means the first one at minus 1, it will be my first turning point. My second turning point will be 1 and negative 2. Remember, we always read things from the left to the right in graphs. In graphs, we read from the left to the right. Okay, so now, even this sentence also, I read it from the left to the right. So in graphs, we also read from the left to the right. So even if I'm talking about my decreasing function in a straight line, it will be from my left to my right. Okay, now we have got the 2 points. So here we're having the first turning point on my left. Then from there I've got the second turning point. The first turning point is the maximum. The second turning point is the minimum. So which means that the 1 and the minus 2 will be my minimum. That one will be my maximum. So I've got a maximum and a minimum. Once you know this, you will be able to draw correct sketches. Because when you know that your A value is negative, you are able to figure out, okay, my graph is increasing and then decreasing if it's positive. When A is negative, it starts by decreasing, then it's increasing. The first turning point will be the minimum, the next one will be the maximum. If it's positive, the first point will be the maximum, the next one will be the minimum. So you can make notes on it. All right. Okay, now, what I like about the graphs, the cubic graphs, is that, mostly you find that, the question, they don't just say sketch the graph of h of x equals to that, and then they give you 15 marks. So what they do is they give you a sketch, because we don't want you to be scared of those marks. Can you imagine if they say sketch the graph and they give you 15 marks, or they give you 10 marks, they say sketch this graph. But in this case, in the question papers, what they do is they given the sketch and they ask you questions that leads to you to draw the sketch. Okay, so they give you the question. Let's look at this one. Here we have got 5 questions that will lead us to draw the sketch. 4 questions that will lead us to draw the sketch. Let's look at the 4 questions. The first one says, write down the y-intercept of the graph. Y-intercept of the graph. I'll just need to put marks here. So there will be 1 mark. 1 mark. So it means that I must not do a lot of stuff there. It's 1 mark. So there's not much that I must do. Okay, so what does this mean? It means that now I'm looking at, to get my y-intercept, remember, to y-intercept is when the x value is 0. So I'll check. X is 0. That will give me a 0. If I put a 0 there, it will still give me a 0. If I put a 0 there, it will still give me a 0. And 0 minus 0 plus 0 will give me a 0. And then we've got 0 minus 4. Already I know my y-intercept. My y-intercept there will be negative 4. What I want to advise you to do is, as you do this question, draw your Cartesian plane and then indicate there. My y-intercept is negative 4. Just indicate negative 4 there. Already you know that you are having a point. 1 point, negative 4. Because when we want you to draw the sketch, we want you to indicate all the intercepts with the axis. So in this case, I've already indicated that on my sketch that I'm going to draw. So I already know that the y-intercept, because that will help you to see if you are on the right track or not. Okay. Now, already we know that this is a positive graph. This is a positive graph. So it's going to start by increasing and then it's going to decrease. So it's going to start by increasing and then it's decreasing. Okay. Right, so it must start by increasing and maybe decreases and increase. Okay, so I already know the shape. Right. Now, the next one says show that. Love this question. Show that x minus 4 is a factor. So what do you already know? That x minus 4 is a factor. They're telling you. They're just saying show it. Okay, so it means that there must be some working out to do. So in other words, we must work it out. So remember it's an H graph. So my H graph there was x cubed minus 6x squared plus 9x minus. They are now showing that if it's a factor, what do we know? We've done factor the remainder theorem. We substitute the value of x by 4, we must get a 0. But we must do it. We cannot just say equals to 0. So in other words, we must come here and say h at 4. How do we get h at 4? Remember, it's x minus 4. We equate it to 0. Then we say x will be equals to 4. We take that 4, we substitute it there. So we're going to have 4 cubed. I want you to put that in brackets. Minus 6 into 4 squared plus 9 into 4 minus 4. Now you can use your calculator. Because now I don't have my calculator with me, I'll know 4 squared is 64. Then I know 4 squared is 16. 16 times 6 would be 96. Then 9 times 4 is 36 minus 4. Then I can say that if I add 64 and 36, I get 100. 100 minus 4 is 96. 96 minus 96 is 0. Then I can then say x minus 4 is a factor of h. Okay. So, can you see that this question also is building up on that? So I already know that, oh, x, if I come to my graph here, the one that I was drawing, I already know that I've got a minus 4 here, I've got a 4 here. Why? Because x is going to be one of my factors. This one is my y-intercept. This one here is my x-intercept. Okay. So I already know where the graph is going. Okay, so my points are there. I already have my points. So I'm building up and drawing my sketch. See, so it says hence. So hence means use whatever you got in the previous one to do the next one. So I'll say hence determine the x-intercept of the graph. Already I know one factor. So remember I've got h at x is equals to x cubed minus 6x squared plus 9x minus. For me to get an x-intercept, it means that the y must be 0. So in other words, I'll have my y is this one. So it will be 0, so I'll have x cubed minus, and it is very important for you to write this step, plus 9x minus 4 equals to 0. It's very, very important because now you are solving for x. So you cannot solve it for x. In this case, you're having an h of x on the other side. So the y value is 0. Already I have got one factor, x minus 4, and I need the other factor. So I can use, from here, we can use any method. Remember, previously when we were doing polynomials, we said we can use by inspection, we can use synthetic method, we can use long division method, you can use a calculator. So it's your choice. You can use any method that you want in there. So remember, if I use my long division method, it means that I'll have z x minus 4, and then from there I can have my f of x here, and then I can use the long division method. For synthetic, remember I can have that, and then I just write down the coefficient of that, and then you are able to do that. I know your teachers love synthetic methods because it's quite easy. This one now we're going to look at the inspection one, which is also quite easy. We're having x minus 4 as one factor. Then I know for me to get x cubed, I must put x squared here, because x squared times x will give me x cubed, right? For me to get a negative 4 from negative 4, it means that I need a plus 1. So minus 4 times plus 1 will give me a negative 4. Then I look at this one here. So remember, for me, I must multiply this one first. So I'll get minus 4x squared, right? Then I can say plus kx. So if I multiply these two here, I'm going to get plus kx squared. And this answer I must get negative 6x squared. So I'm only interested in the negative 6x squared, not the 9x. Okay. So I know I'll get the 9x anyway. So here I can just remove the square, so I can just have minus 4 plus k equals to negative 6. Can get a value of k that is negative 6 plus 4, and k will be negative 2. So my equation will be x minus 4 and x squared minus 2x plus 1 is equals to 0. If you multiply this, the 9x will come out. So I'm going to write down the values of x. So before I write down the values of x, I can factorize this. X minus 1 equals to 0. So I can see the x value will be 4, or I already have the 4 in my sketch. 4 or 1. Or 1. Now we have got 3 x values there. So we're going to look at when we sketch the graph. How are we going to sketch the graph? We have a 1 and a 1, and remember the x-intercept, the x-axis has only got one number there. We don't have a 1 and a 1 somewhere. We have 1. So we're going to look at how we're going to then draw the sketch. Okay, let's look at the next one. The next one says we need to get the coordinates of the turning point. Remember this turning point here, the other way that they will use will be the stationary point. The stationary points make sense because that's where the gradient is 0, it's stationary, it's 0 there. Okay, right. Now determine the coordinates of the stationary points of the graph of H. Writing the equation again. H of x is x cubed minus 6x squared plus 9x minus 4. Now, how are we going to get the stationary points? Remember, stationary points are nothing else but we in the gradients at a certain point. So, which means I need to differentiate. Now, how am I going to differentiate this? So, it will be 3x squared minus 12x plus 9. But when I differentiate, because it's stationary point, it means that I must equate it to 0. So that's 3x squared minus 12x plus 9 is equals to 0. Remember, now I'm now going to solve for x, so it means that this graph will have two stationary points, because when I factorize this, I'm going to get two x values. So I'll have, can divide throughout by 3, so I'll have x squared minus 4x plus 3 is equal to 0. Then I can factorize. If you can't factorize, this is a quadratic formula. X value there and the x value there. We have got a 3 and a 1. I think the signs will be negative, negative. X is 3 or x is 1. Now I need the corresponding y values. It means that now I must substitute the value of x by 3. So I'm going to do it here. I'll do it there. So I'm going to substitute the value of x by 3. So I'll have 3 cubed minus 6 into 3 squared plus 9 into 3 minus 4. So I'll have 27 minus 3 squared is 9, so there will be 54. Then we'll have plus 27 minus 4. So if I look at this, 27 plus 27 is 54. 54 minus 54 is 0, so my value of that will be negative 4. So which means that the y value, if x is 3, will be negative 4. Right. Now if I substitute by 1, do I really need to substitute by 1? I already know. Already 1 was the x-intercept. So which means the y will be the x-intercept. So which means the y value will be 0. But let's do it. So we'll have 1 minus 6 into 1 squared plus 9 into 1 minus 4. So I'll have 1 minus 6 plus 9 minus 4, and this answer will give me 0. Because 1 plus 9 is 10, minus 6 minus 4 is that, so I'll have 0. So or y will be equals to a 0. So my stationary points will be 3 and negative 4. And the other ones will be 1 and 0. So if I had to draw my sketch already, if I can just do this and put my graph there, I already know that I've got a negative 4, I've got a 4. Now I have a turning point. My turning point is 3 and negative 4 is somewhere there. I already know I've got another one here at 1, and that is somewhere here. I've got my first turning point, my second turning point. So what do I know about the a value, which is positive? So can you see I've already drawn my sketch. My first turning point, if a is positive, will be a maximum. My second turning point will be the minimum. Then I put all the points in there. So all my points are done. The next thing that I just need to do is to sketch the graph. Okay. Sketch the graph of showing all intercepts with the axis and the stationary points. So for you to get the marks, you must show all this. But already when I was doing all those things that I was doing, I was showing you that these points can be put on the sketch. So now let's see if I can put this on the sketch. I said this one is going to be a negative 4. Remember, in your exam, your sketch will have some, will be up to scale. So remember this, we said is negative 4. I'll try to, that is a 4. Then we said we have a 1 there. This is my x-intercept. This is my turning point and x-intercept. This is my x-intercept. We have another turning point at 3 and negative 4. So I'll just 3 and negative 4 will be somewhere there. Right? So we've got two turning points, so I'm going to do this. Now, so which means my graph must pass at this point, must turn there, must turn here, must pass at this point. So, the first turning point we said is the maximum. So I'm going to draw a maximum on my first turning point. My second turning point is the minimum, so I'm going to draw a minimum on my turning point. I'm done with my graph. So I'm going to then join this, join this one, and join this one, and I'm having my graph. So already I've put the points in here. My turning point is 1 and 0. There we have a 4. My turning point is here is -3 and +3 and -4. Right? Then I've got my y-intercept, and there's no child without a name. The name of that child is H. So I write H as my graph. So sketch the graph of that. I'm done with that graph. Quite easy to draw that sketch. Alright. So my sketch drawn, and then from there you get full marks for drawing that sketch. Okay, now with the sketch drawn, I want to explain this here. Remember we said we've got two x-intercepts. I think our x-intercepts were x minus 4. The other one was x minus 1 and x minus 1. Right? So we got x equals to -4, and so +4, or x will be equals to 1, or x will be equals to 1. So can you see these numbers are the same? So that x-intercept is 1 x-intercept. So if you see something like this, you must know that that point, this point here, x equals to 1, will also serve as a turning point. So it will serve both. It will serve as a stationary point, stationary, and also serve as an x-intercept. So your graph will be x minus 4 and x minus 1 all squared equals to 0. So in other words, if you see that, you must know that that point is going to serve as a turning point, stationary point, and also serve as an x-intercept. So we have that one point as x-intercept and also as a stationary point. Please note that. Okay. Right. Obviously, the questions, oh, there's the graph in the next one. So you can see that graph is there. It passes at -4. Stationary points here, stationary point there. Graph increasing, 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 decreasing, 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 increasing, increasing, increasing. Oh, by the way, we are now answering that question. Huh? Determine the values of x for which the graph of h is increasing. You see, where the graph of h is increasing. So the graph here, remember we read the graphs from the left to the right. We don't read them from the right to the left. So if I'm reading this graph from the left to the right, the graph here is increasing, increasing, increasing up to here. So the graph will be increasing from 1 to the left. So from this point 1 to the left, the graph is increasing. It has been increasing, increasing, and it stops increasing at 1. So how do we write down so this one is increasing. Now we need where the graph is decreasing. So from -1 to the left, the graph has been increasing, increasing, increasing. From 1, the graph starts decreasing, 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 up to 3. So from here to there, the graph is decreasing. And from 3 to the right, the graph starts increasing. So where is the graph decreasing? So it is from 1 to 3. But you remember in grade 10 we've done notations. We need to write down this in the correct notation. You remember in grade 12 when we mark also the notation. So you must understand the notation, writing that in the correct notation. So how do we write it in correct notation? We'll say x is an element of. Remember, if I put this bracket, if I put square bracket, square brackets will mean, if I put it like this, square brackets will mean that I am including the 1 and the 3. But if I include the 1 and the 3, then at 1, it's stationary. It's not decreasing. So which means that that bracket, those brackets will be wrong. So which means that I need to write the round bracket 1 and 3. All round brackets. In grade 10, we have done this notation. Let's go back and revise them. The round brackets means that the 1 is not included, the 3 is not included. If I put the square brackets, it means that they are both included. And once I say they are both included, I can see that at 1 it's stationary, it's not decreasing. At 3 it's stationary, it's not decreasing. So that's how we write it. Or we can write it like this. We can say x is less than 3 because it's less than 3, decreasing, but it's greater than 1. So we can write it like this. The notation must be correct for you to get your 2 marks. So there will be 2 marks. 1 mark for the values, for the endpoint, 1 mark for the notation. So we must write it like this. I know sometimes then you don't understand that in the exam you just write from 1 to 3. See, and then sometimes, you know, when it is not included, then it gives us a bit of a problem in terms of us trying to allocate marks for you. So please, let's write it in correct notation. Let's learn this notation. X is an element, 1, 3. Then 1 and 3. Endpoint, x in the middle, less. Don't write less or equals to or greater or equals to 3. Right. The next question, G, it says, for which values of x is h of x less than 0? That these two questions are different. The first one was talking about decreasing, where the graph is decreasing. But this one is saying, where is the graph less than 0? Below the x-axis. Where is the graph below the x-axis? So I can check the graph is below the x-axis all the way up to here. Right? It's below the x-axis. But be careful of this. Okay. Because there it is equals to. So there's no equal sign. So we're going to break this down into 2. So I'm going to say your answers are going to be, your answer first is going to be from 1 to 4, right? From 1 to 4, the graph is below the x-axis, right? So I'm going to say x will be less than 4 and x will be greater than 1. So I'm going to write it like this, right? The next one will be x will be less than 1. You can see I've got 2 of them there. So it's where x is between 1 and 4 below the x-axis, and x is equals to 1, therefore it is on the axis. So in this case, x between 1 and 4, the other one is x is less than 1. So we have those solutions. Okay, right. See, if this point was somewhere there, here, I'll say then x will be from -4 to -infinity on the other side, okay? Right, so now, but in this case, I'll write it in this form. Remember the other notation, I can write x is an element of, then it will be 1 and 4, right? Or the other one will be x is an element of, remember we start with -infinity and then up to 1, right? So remember -infinity is not included, okay, because we don't know what that last number is. Never ever with positive infinity you don't write a square bracket. So with infinity and -infinity, no square bracket at all. Even if you've got x less or equals to here, you don't write infinity. Okay, right. The last activity that we're going to do now is activity 7. Nice question here. And let's see how we can be able to draw this sketch. First of all, we know that the graph is it's positive here. Yeah, why do we have so many positive graphs? Right, positive there. What happens now is that the graph will start by increasing, and then decrease somewhere. Okay, but let's see how this graph will turn out. Get the graph of f of x equals to x cubed minus 1. Sure. Step number 1. Now let's go back to what we've been doing. Step number 1. What did the first question was calculate the y-intercept of the graph. Calculate y-intercept of the graph. How am I going to calculate the y-intercept of the graph? So I'm going to say f of 1 is equals for f of 0 is equals to 0 cubed minus 1, and that will be minus 1. F of 0 will be minus 1. So that will be the y-intercept of the graph, right? So it's minus 1. Okay, so when I have the x-intercept of the graph, then I can just quickly draw my graph there, and then I'll write minus 1 here. That's my y-intercept, my x-intercept. So I'll have minus 1. Already I've got 1.9. Okay. So I know my graph is going to be increasing, decreasing, but look at this graph, how it's acting. Step number 2. How am I going to, step number 2, it means that I must get the x-intercept. Okay. How am I going to get the x-intercept of this graph? The y value must be 0, so I'm going to say x cubed minus 1 is equals to 0. And this is the difference of 2 cubes done in grade 10. Okay, so now how do I factorize this one? One thing, I know some of you can just transpose and get the cube root of both sides, né? Right. But you know the rule of factorizing. I know the other part will not have a solution, but you know the rule of factorizing your cubic function. You know, I mean, sorry, your difference of 2 cubes. So you know when you have a cubed minus b cubed, it's equals to a minus b. Then you have a squared plus ab plus b squared. That is the rule. So in this case, what will we have as our factors here? I'm now going to have x minus 1. And this is the same as 1 cubed. Ne? So I'm going to have x squared. I'm having x times 1, so I'm going to have plus x. Then I'm going to have plus 1, and then equals to 0. Then this part here, if I use, I'm going to say x is equals to 1. I see I cannot factorize this. Or if I use a quadratic formula, I'll get minus 1 plus minus the square root of b squared, which is going to be 1 in this case, minus 4 into 1 into 1. That is divided by 2 into 1. So I'll get minus 1 plus minus the square root of 1 minus 4 is minus 3 all over 2. And here's my problem. I have x. What is inside the square root is minus 3. And I can see you guys saying, no, say, we can put it as I because we know complex numbers. But remember, when you're doing graphs, we're dealing with real numbers, not complex numbers. So we're dealing with real numbers. Remember, our Cartesian plane is a real number Cartesian plane. Does not have an imaginary and complex. I know you have done complex numbers, the beginning of the year. But in this case, we are dealing with graphs. We are dealing with real numbers. So what are we going to say when we're dealing with that? We're going to say there we don't have solution. So we don't have a solution. I know you're saying, but we did complex numbers. No, I know you've done complex numbers, but in this case, we're dealing with a Cartesian plane that does not have an imaginary axis. It has a y-axis and an x-axis. So dealing with real numbers, then we need to say no solution. So the only x-intercept that I'm having is x equals to 1. So on my graph, I already have the y-intercept is -1. Now I have the x-intercept is 1 here. Alright, so doing very well. So now, I come to the next step. The next step there is to get the stationary point. So now with the stationary points, what do? We are going to differentiate. Remember, to get a stationary point, we differentiate. Why? Because at the value there, the gradient is 0. We equate that to 0. We get the gradient. So we're going to get 3x squared. -1, that will be 0 there. So we equate this to 0. Lovely. X squared divided throughout by 3, you get x equals to 0. When you take square roots on both sides, we're going to get x equals to 0. The y point will be 0 cubed -1. So which is going to be -1. So my turning point is 0 and -1. If you have looked at what I've drawn there, I have a -1 here. Y-intercept, x-intercept. I've got a 1 here. So my turning point now is also here on the y value, because the x value is 0, the y is 0. It's going to be a very strange graph. So I've got only those 2 points. Can you see I've got only those 2 points? I've tried the x-intercept, the y-intercept, the turning point. So I'm having only 1 and there. And this graph is a cubic graph. It can never be a straight line. I cannot join this point and that point and get a straight line. That is going to be incorrect. So what will be the plane now? I have those 2 points, and how do I then draw the graph? Because it means that I must join this graph. We have got only one value of the turning point there. So if I've got 2, I'll know that the first one will be maximum, the second one will be minimum. But in this case, I only have 1. So I cannot have a maximum and minimum at 1 point. So what should I do? Right, look at it now. Here's my graph here. I'm saying this is going to be, my point here is -1. My point here is 1. I know this is my x-intercept. That is my turning point and also my. So the plan that I can make here is, remember I have got this graph here. So I must just choose some points to work with here now quickly. Let me choose the points that I'm going to work with. So I'm going to say, let me see what will happen if I substitute by -1. Let me see what will happen if I substitute by -2. Let me see what will happen if I substitute by 2 there. So in other words, so that I can have a proper graph. So if I substitute by -1 on this graph, so I'm going to get -1 cubed -1. So I'm substituting by -1. So I'm going to get -1, -1, which will give me -2. So now if I substitute by -1, I'm going to get a -2. That's the point that I'm looking for. Seems like it's giving me a straight line again. Then I substitute by -2. I know if I substitute by -2 there, I'm going to get -8, -1, which should give me -9. So somewhere there, I'm going to get a -9. Right? If I substitute by 1, then I'm going to get a 0. It's fine. If I substitute by 2, I'll get 7. So I'll get somewhere there, 7. So my graph, because this looks like a turning point, so my graph will go like this, and from there it turns a bit here and then it goes there. So my graph will then do that. There it must turn a bit, and you can see this graph is increasing. Okay, so this graph is very important for you to go and practice. So it means that at least if I've got those points, those 2 points, I'm fine, but I just need to get to other points so that then I can make sure that my graph is correct. Okay, so the graph of that, so mostly this point here is a turning point. We call it a point of inflection. Okay, so that's where the graph makes its turn. So that point here. So can we then say we have a maximum and a minimum? No. Okay, so we cannot have a maximum and a minimum on that graph. So that graph there, that point there is called a point of inflection, and we're going to use that point of inflection to make a turn there. Okay, so please practice this graph where we have an x cubed and we have a number there. So if that graph was x cubed only, obviously it will go like this, and then from there it will turn at 0 and 0 to make a small turn there at 0 and 0, and then you make that. Okay, right. So now these are the cubic graphs. So you go and also practice your cubic graphs where we have negative. Remember, with a negative, as I said, the graph will start by decreasing, increasing. So if that graph was a negative there, obviously it will start by decreasing and go down there. Okay, so if it was a positive, it goes like that. So you practice the graphs of negative and you know how to draw those sketches. And remember, you've got a 4-point plan to draw the sketch. 4-point plan, so your 4-point plan to draw the sketch, 4-point plan to draw the sketch. The first thing that you need to do, your y-intercept, which will always give you 1 mark. Okay, so the next one, it will be the x-intercept, where you're going to use your methods there, you know, your long division, you're going to use your synthetic, you're going to use method by inflection, you're going to use the calculator, so you can use all these methods to do your x-intercept. Then the next one is getting the stationary point. How do I get the stationary point? I use a derivative. So I derive. Okay, so to get the derivative, I get the derivative. Then from there, the last point there, it will be to sketch the graph. Okay, so the last one is to sketch. So it's a 4-point plan. Practice all those. So you get ones with a lot of marks, those 2. Once you get those 2 right, then your sketch will be correct. Even the y-intercept, obviously, because that one is quite an easy one. Okay, remember, sometimes you'll be given 3 brackets. For you to get the y-intercept, you must multiply out only the number, then you get the y-intercept. So please make sure that you understand all those type of graphs that are given. Don't do only one. Please practice a lot, because there are so many ways on how the graph can be given to you. So it can be given to you in a factorized form. It can be given to you as in that form, or it can be given to you in a form where you have x minus a squared or cubed, and then you need to expand it and then get the correct form. Then you're able to can do the derivative. Remember, if it's in a factorized form, you will not be able to derive. You need to first multiply it out all those 3 brackets, then you are able to can derive. Because for you to get the stationary point, you need to derive. Okay, right. With those, I want to say thank you so much. Go and practice your graph. Thank you so much.